Pascal's principle. Pascal's principle states that if an external pressure is applied to a confined and incompressible fluid, the pressure everywhere in the fluid increases by that amount. On the left is a picture of an experiment attributed to Pascal called Pascal's barrel. Now, it was very unclear whether he ever performed it, but nevertheless, in this experiment, a 10-meter long tube was inserted into a barrel filled with water. When water was poured into the tube, the increase in pressure caused the barrel to burst. As an aside, I mentioned the word incompressible. Incompressible means cannot be compressed. For any material, it means that the density is unaffected by pressure. Let's look at Pascal's principle and hydraulics. An important application of Pascal's principle is hydraulics. Here, the application of pressure via piston at one surface of a fluid is transmitted through the fluid to another piston. Since the pressure has to be consistent throughout, we have P in equals P out. If we use the definition of pressure, force over area, we get F in over area in equals F out over area out. So we have a force being applied over a small area here on this piston, and on the other side we have a larger force applied to a larger area in this piston. The result, a small force, F in, applied to a small area, A in, results in a large force, F out, applied to a large area, A out. Well, how does that work? Well, what you have to realize is that the work done by both pistons has to be the same. As one is pushed in, the other one has to do the same amount of work going out. So the difference is that F in, the small piston, will end up pushing a much greater distance than F out.